Okay, so in this question, it asks, a student reacted 50.0 milliliters of 1.00 moles per liter of NaOH and 50.0 milliliters of 1.00 moles per liter of HCl in a styrofoam cup calorimeter. The temperature of the water rose from 21.2 degrees Celsius to 28.5 degrees Celsius after the NaOH reacted. Calculate the molar enthalpy of neutralization for NaOH. All right. So immediately we can see we have a change of temperature. So we have to use our Q equals m times C times delta T formula. We have to write that down. And we also see the main objective is to find the molar enthalpy of NaOH. So we have the molar enthalpy formula, delta H equals N times HM, or more specifically, HM equals delta H over N, N being the number of moles and H being change in energy change, either release or absorption of energy. All right, so to the actual formula now. So to start, we need to find our Q. And we already have our mass and we already have our mass, which we're going to be looking for the Q of HCl. So in this case, we can take the 50 milliliters and change it into grams, since milliliters and grams are convertible directly within each other. And then the C we need to find is our specific heat capacity. And since this is a solution, we can go over to our to our table here in the data booklet and use the water specific heat capacity, which is 4.19 joules over grams times degrees Celsius. So we can insert that into our formula. And to find our temperature change, we simply take our final temperature minus our original temperature and get our change in temperature. And then we're going to multiply all of these together, leading to this number in our joules. And for convenience sake, for later on, we're going to convert this number into kilojoules, and we're going to keep it with 3 significant digits. As we can see in the question, every number mentioned within the question has 3 significant digits. So our Q ends up equaling 1.53 kilojoules. Then we have to convert it over into our delta H, since Q and delta H are both the absorption or release of energy. But to do so, we have to flip it. So our delta H becomes negative 1.53 kilojoules. This is where our molar enthalpy formula now comes into play. So to find the molar enthalpy of NaOH, we need to do delta H over N, so change in energy over number of moles. And then we have to figure out, we know our delta H, and we're going to be looking for that. So we need to know what our number of moles are. So we're going to go over, and there's 2 possibilities to search for N, either mass over molar mass or concentration times volume. In the question, there's no indication of an immediate mass, so we know we won't be using that, but we do have concentration, and we also have volume. So we're going to use that in our formula. And so within this formula, we have 0. If it clears up, we would have 50.0 milliliters times 1 mole per liter. However, once again, for convenience sake, we're going to immediately turn the 50 milliliters into liters. So we're going to divide 50 milliliters by 1,000. So we can get to 0.05 liters. If that clears up, that would be nice. 0.05 liters. And moles per liter. So using our basic knowledge of unit analysis, which is just canceling different units, we can cancel out the liters and liters, and now we'd be left with moles. And since it's just 1 mole, our total number of moles comes to 0.05 moles. And now we have both of our units we need. To find the molar enthalpy, we simply do negative 1.53 kilojoules divided by 0.05 moles, and we come to a total answer of negative 30.6 kilojoules per mole as our final molar enthalpy of sodium hydroxide. And there is everything. 0.05 isn't very clear.